Hello, I am Sparsh and I am a software engineer and welcome to my YouTube channel. This is like one of my first videos I have ever made, so bear with me. But as my first videos, I just wanted to show one of the projects I have built recently, which is a password manager. Now you might be thinking, what's new with a password manager? Everyone has built it as their personal projects. Well, in my password manager, I decided to do something different. I decided to put myself in the place of a user and thought what all would I expect from a password manager. And when I put myself in that perspective, the bar of or and the quality of features that I expected from this simple password manager increased dramatically. Yes, so today I'm just going to show how I built this project and what all decisions I made and how I made it, including with an architectural diagram and all that shit. I hope you will enjoy this and let's get straight into it. This is like the high level overview or the architectural diagram of my project. So let me just walk you through it and tell you what is actually going on in my project. Yeah, the first is the user interacting with the web app, and then he has to log in using Google. When he logs in using Google, the first thing which happens is Google sends an ID token to the client, then it hits the backend using this endpoint where the ID token is verified and a session token is created and set in the HTTP cookies. Why HTTP cookies? Because you can securely get the user data using this endpoint from the backend whenever you want. And the second thing which happens after login is my app checks whether the vault has been created or not for this user. If the vault has not been created, it creates the vault using this endpoint. I'll go in depth later how the vault is created. And if the vault has already been created for the user, it asks for the master key. You might be wondering what vault is here. Vault is basically a storage or a safe where all your passwords are stored. And to unlock that vault, you need a master key. So yeah, when it receives the master keys from the user, it also retrieves the UID of the user, and then using these two things, it creates a key. Then it basically gets the vault metadata which stores the IV. IV I'll get into later what it is, and the encrypted form of vault dash open. Then it tries to decrypt the encrypted password, and if it is equals to vault open, then you are able to log in into open your vault. But if it is not, then it asks for the master key again. It also stores the key which is created using UID of the user and the master key in a Justin State Manager store, so it can be easily accessed throughout the application whenever I want. So when a user creates or generates a password and try to store it, it uses the password generated password, which is also known as the plain text, the key which is stored in the store, and a randomly generated IV, which is also known as a nonce. To encrypt the password, Then it checks whether the user is logged in using the middleware I have coded. I'll show it to you later. And if the user has not been logged in, it will show an error. But if the user is logged in, then it will save the encrypted password in the Firestore database. You might have guessed by looking at this architectural diagram that I have chosen a client-side encryption model. Why? Because I wanted to make users' password as secure as possible. Client-side encryption basically means the server and the database never sees your plain text passwords. It always sees the encrypted passwords, so even I don't know what your password is. So let me talk a bit about the master key and how it works, and how do we verify the master key and open the vault if we never store it. Yeah, master key is one of those things that we never store. So yeah, this is the encrypted form of vault dash check, and this is the IV which is stored in the database. For the master key, only this is the two things which are stored. Now let me talk a bit about IV. What IV is? IV is basically a randomly generated string which is used with the encryption algorithm to create encrypted passwords. I have chosen the IV to be random because if this is the same, the relationship between encryption and decryption, yeah, or the formula of decryption and encryption can be cracked by users. This makes it very hard for anyone to crack and decrypt your password. This is the code responsible for opening the vault. So basically, it checks whether the master password entered by the user is correct or not. It basically first checks whether the vault has been initialized or not, whether the vault exists or not. Then it uses the master password and the UID of the user to create a key. Then it uses that key and the IV from the database that I have shown you to decrypt the password and convert it into plain text. If the plain text is not equals to vault dash check, we know the master password is invalid, because if it was valid, it would have been decrypted correctly. This is how the key is being derived using the master key and the UID. This is the code which is responsible for encrypting the password. It received the plain text password and the key which is created here, and then it generates an IV string, a randomly generated IV string. Then it uses the IV string, the algorithm, and the password and the key to encrypt the password, and then we return that encrypted password. Similarly, we decrypt the password using the encrypted password, the already established IV, and the key. If you are wondering how IV is consistent during encryption and decryption, we store the encrypted password and the IV together in Firebase. This is the schema of how your encrypted passwords are stored. It has an encrypted password and it also has an IV, so we can use this IV and the encrypted password and the key to decrypt it. I've already touched on how authentication works, but let me go in depth and tell you how it actually flows by showing you the code. So when you reach the login page and click login, I use Google's to allow you to log in using your email ID and get your ID token. This ID token is sent to this API endpoint, which kind of looks like this, where it is then verified by the Firebase to see whether it's valid or not, and then creates a long lived session cookie. This session cookie is then set in the HTTP cookie so it can be accessed at any time. You can retrieve the user data anytime you want from the backend using this API endpoint, which basically gets the session cookies from the cookie and then tries to verify whether the cookie is correct or not, or whether it has been expired or not. If it has not been expired, it returns a user decoded user data. Now let me show you something interesting. Every endpoint relating to Vault has this part, require auth, which is basically a middleware of which checks whether the user is logged in and the session cookie has not been expired before performing any function relating to the vault, which just adds an extra layer of security. This is how the middleware looks. It has two ways to retrieve the ID token. First is the authorization header way, which is used for the extension that I have built as a complementary to this web app. And second is the session cookie, which is primarily used by the web app to get the session token. Now I will show how the user will actually interact with my web app. First, of course, you have to log in using Google. Now that I have logged in, this is my first time logging in with this account, so it is asking me to set up my master password. So I will just do that. Now when I set up my master password, every time I reload this website, it's going to ask to my master password to unlock the vault. Yeah, as you can see, it is now after reload asking me to enter my master password. Right now I haven't stored any password, so let's click add and store a mockup password. Here you have the option of adding the password manually by clicking this, and but I'll just going to generate. As you can see, it has generated the password, and now I'm going to save the password. If you are able to remember this because I'm going to show you how it looks after encryption. See, this record has been created, and this is the encrypted form of the same password. You can also delete, favorite your password, and you can also unhide your password, copy the username, etc., and open the website using this button. So let me talk a bit about the browser extension I have built for this web app. Before going into the code, I would like to show you how the UX user experience looks like. When you open it for the first time, it is obviously going to ask you to sign in. You can sign in the same way you used to sign in the web app. Then you are going to type your master password to unlock the vault. Here it automatically detects the name and the URL of the website. You can obviously enter some username. I just used a random one, and let's enter the Gmail account. Here you can obviously choose to enter the password manually or generate it. Here also I'm going to generate the password. You can copy the password and now you can save it. I have also implemented the feature where you can easily get the credentials of a website you are on if you have stored the password in your vault already. You can do it by just clicking this button. As you can see, it gives all of the information related to that website that you will need, and you can easily copy paste your password from here. I can also show you that it has been stored in the database. When I reload it, you can see that the extension password that I tried saved using the extension is already here. Now let me jump into the code. This is the front end code of the extension, where it dynamically using if statements render different part of different pages in the same pop-up. Basically, I want to show you one more thing, which was this app URL. I haven't defined it anywhere in the code, but this is a variable which is filled during build time, and I'll show you how. But before that, I'll show you the back end of this, which is this. It is also known as the background worker. It basically receives messages from the front end and performs certain tasks, like again whether the vault exists or not. This app URL is the domain name of the web app, and it is filled in build time. Basically, if I am building this extension in production, it will give the actual domain name of the web app, but if I am building it in development, it will give it the local host domain. Now, to end of the video, let me tell you how I have set up this project. I chose a monorepo setup for this project to first have the web app, which is stored here, the extension which is stored here, and the common packages like the the code I showed you related to decryption, encryption, etc. This allowed me to reuse the code again and again and have global rules for my project, which was really helpful when the project became more complex. Well, that was it from my side, and this is the end of the video. I hope you liked the video, and if you like, don't forget to like and subscribe and comment your feedback regarding my project. I would really appreciate it. Thank you, and I am signing off now.